All right, solving a distance, rate, and time problem using a linear equation. Basically, all solving distance, rate, and time use the general formula: distance equals rate times time. This is a formula that shows up in physics. We shows up in a lot of math problems. It's one that we use a lot of times, so I do recommend knowing it. If you see distance, you probably need distance equals rate times time. All right, so we have word problems. Yet again, I do it sentence by sentence and try to make sense of what we have. Knowing that it's a distance, rate, and time problem, I'm going to use that formula. All right, so two cars leave towns 800 kilometers apart. Okay, so we have this town here, high tech, this town here, high tech, and the distance between them, total distance, is 800 kilometers. So they're leaving at the same time. So one car's rate is 16 kilometers per hour less than the others. Awesome. If they meet in 4 hours, so I know they meet in 4 hours, that tells me T equals 4 hours. What is the rate of the slower car? So this is distance, so this is D. They're going towards each other, but their speed, basically, they're eating up that distance. So they're going to be coming together. So we have car 1. All right, I'm going to put it here. Car 1. Car 2. I like to usually do distance, rate, and time. We've got the distance marked already for the whole thing. Time for both of them is 4 hours. This is whole slash both slash each. So the time for each of them. The distance, they're each not going the 800. They're both together covering the 800 kilometers. I know one car's rate is 16 kilometers per hour slower than the others. So I'm going to call this one X, so rate slash speed. Now I have to write a sentence or an expression that's going to deal with the rate of the other one. I can't do minus 16 kilometers. I know it's 16 kilometers slower or less than the others. So I have to start with the others. So it's X minus 16. So it's always when we have a then in a problem, or you can read that then in there. You do have to have the amount first. The minus goes at the end of the sentence. It goes with the translating, which is in another video. So I know total distance, total equals rate total, and that's going to be both cars. And then time, which is that 4 hours, which is the total. All right, so we can do 800, we know that, equals the rate of car 1 plus car 2. So this is going to be X plus X minus 16. So car 1 plus car 2. Okay, because they're working together when we're thinking about that. The time, the total time is 4 hours. All right, so that has taken all of the information and brought it down to the one equation that we're going to be solving. So we're solving, simplify this mess. Okay, you kind of get a feel for these problems as you do more of them, but for the most part, we're going to be able to combine stuff and look at stuff. Some things should be the same in both of them or be working together. So we have 800 equals 2x minus 16 times 4. Now, you can either distribute the 4 or divide both sides by 4 to get rid of it, however you want to do it. Most people generally do it by distributing. Okay, so this is going to be 8x 4 times 16, 2 times 16 is 32, and then another 2 is 64. So minus 64 equals 800. Okay, adding 64. Equals 8x, almost there, dividing both of them by 8. All right, so 8 goes into 800 one time, so this is 1. 8 goes into 64 8 times, so this is going to be 108 equals x. That seems really fast, but we're talking kilometers per hour. So it should, we'll do a conversion just to double check. So this is 108 kilometers per hour. And this is, I'm going to subtract 16 from it. So it's 108 minus 16. So this is 92 km per hour. And it's asking for the slower one, so it's the 92 kilometers per hour. Double check that that makes sense, looking at speed. Knowing that kilometers per hour, kilometers are smaller than miles. So that's about roughly 60 miles per hour. So these are reasonable numbers, thinking metric system. So my answer is going to be, they want the smaller, so 92 km PH, kilometers per hour, or kph.